Welcome to our last lightning round talk. Today, Intuitive Graph Business Intelligence through Visual Graph Transformation, presented by Weidong Yang. You can now start, Weidong.
Thank you. Hi, everybody. Today I'm going to talk through how can you use graph transformation for a BI kind of a workflow. First, are you guys seeing my slides or seeing my camera? Okay, so I
We're
assume you're
seeing both.
seeing
We're
both?
seeing both.
Okay.
Yep.
Okay, very good, very good, very good. So the first question is really, why do we use graph BI? Why use graph for business intelligence analysis? So we have done quite a few works of applying graph for the BI workflow. What we learned is there's a few key advantages of using graph. The graph turned out is really good for inference. I'll give a couple examples in the next two slides. And the second one is in the real world, very often you have to work with the many different kind of source of the data and to be worth it. And the different data often have different definitions coming from different places. Trying to work them together is really difficult. And with the graph, it solves this problem quite gracefully. But this is probably a topic beyond this presentation. The third one, the reason why we use graph for business intelligence is, well, in the real world, guess what? Things change all the time. So dealing with change, and also in the software industry, called it, you can also call it edge cases. The edge case keep on coming. How do you solve the edge case? How do you work with the edge case? And in the graph compared to the traditional data model, like most prominently relational data model, the graph has a huge advantage. Now let me give you a couple examples of what I mean by inference. So here's later on I'm going to show you example of how do you apply graph operations on a set of a movie data set. And here's the example of, let's see, we have two Wachowskis in the movie Matrix. And on the left, you see two person connect to a single movie, and you can define a shortcut operator. And basically, you can bridge those two actors together as they appeared in the same movie. So that's an inference. It's a very simple example of inference. Next example is look at the same graph. Well, you can do a pattern matching of all your data. And then if you identify, let's say those two person has the same last name, you can create a link called they have the same last name. So that is the inference basic on the link. And by the way, with the graph, you actually has ability to not only create the link, but the link also can have a property. Essentially, you can see here I'm 30% certain that those two persons belong in the same family or something like that. So those are just two very simple examples of how the inference work in the graph. Now, as you can see, compared to the more traditional business intelligence process, this is a lot more intuitive and direct because you really treat your data as objects, and then you really apply logic on the objects directly, rather than through tables and join. And sometimes you have to go through many layers of join. It's difficult to manage. The other thing I want to touch upon is we often think about when you organize data, you need to create a schema, and the problem with the schema is the schema is also essentially cast your data into one specific perspective. In the real world situation, we often find out that you discover the question you want to ask is 90% of the problem itself. So there is a need to you want to find a way to structure your data, to save your data in a stable, manageable way. But then beyond that, you want to be able to continuously evolve your schema to help answer the question. So with those two things together, and we found out that visually, in order to like the graph is very suitable for visual analytics. Uh, but in order to do that, we need to define a language for visual analytics. And I'm going to show you one simple example of one of the traditional operations, very common operations, and how it's going to be done in the graph. And then I'm going to move on demonstrating a simple example of how a set of simple operations can perform some of the very complex analysis. So this is a simple aggregation example that you have this actor in the center. She's involved in many different movies, and then you can ask many questions like how many film has she ever made, what's the average payment, something like that. Now, in the traditional way, you're probably going to do a SQL select and then do aggregate. In the graph context, however, you can just directly pull the data from neighborhood. You can select the kind of relationship you want and then pull the data from a neighbor. And it's a very much more direct, intuitive process. So the next, I'm gonna spend a few minutes just give you a quick demo of how this graph operation works. And the data is provided by our friend Rudolph. And let's see how can I share my screen. Are you guys seeing my screen? Okay, so I have a simple examples of basic just actor and the film, and I have a photo link for the actor and photo link for the film. So this is GraphXR, that a visual graph analytics that we developed at the Kinavis. And in the back end running is a Neo4j database. So let me drag this CSV into the GraphXR. So we see there's 89 records. So in this context, we treat each line of CSV as a record. And once we have in, we can see, okay, I want to find the actors. And the actor is, the record is of the actor of, and we put actor, and we put actor film, a photo. Now, from this simple record, we figure out what's actors involved in those records. The next thing we can do is we can pull movie out. Now it's about movie, and we want to use to film and get a photo. So now you can see through this record we build a actor, our record, and the movie relationship. So the next thing you can do is, now I just at some point I can drop the film, the record. I just want to directly relationship between actor and the movie. So about movie, then what I want to do is I want to build a shortcut. Once you have the shortcut, you can get rid of the original, the raw direction, raw record. So what you get now is a actor movie relationship. So this simple operations allow you to transform your original data, raw data, into something much more complex. I'm gonna, for the time's sake, I'm gonna skip next to demonstration, which is you can link those nodes together and you can do the aggregate to the some of the traditional business intelligence tasks. And once you build all your graph from your raw data, evolve into schema you want, and then you can just sync to Neo4j um, that allow you to use it for the other context. So I already saved in the Neo4j in this way, and you can see the schema is created from, and you have the raw data. This is the raw data you imported, and you create I believe this is the movie and this actor, and I have a couple more extra relationship being created in this case. So let me stop sharing. All right, now let's see, stop screen sharing. Now where's my, yeah. So that is what I want to share with you today. Thanks so much, Neo4j, for organizing this fantastic online conference, and thanks everybody for your time. Do you guys have any questions? I think there is a question about, can you transfer back to CSV? Yes, once you organize into the graph, you can export to a graph format CSV. Actually, there's also on a couple questions.
Some questions
Yeah,
just came in.
let me see. What are the questions? The next question: how many nodes edges does the system visualize well? That's a really good question, and I think that this is actually, the answer is the twofold. The first fold is how many node edge can the visualization handle. The second question is how much node edge can a human perceive well. So one of the things I did not touch upon is our approach in the graph transform is not only transform the schema, but also to reduce the either reduce node edge or reduce the structure to something that's more accessible for human perception. We have rotating put about 40,000, 60,000 nodes in there, and the system can handle more. But from our experience, that in the end, you always want to get to lower numbers for presentation and communication. Yeah. And I see another question. Can you export the modified schema? The short answer is yes, and also what I did not demonstrate in the GraphXR when I demo is, so you can actually save like take snapshots along the way when you work. So essentially, you can have multiple versions of schema in the same work sessions, and then you can go back to them later. I think there's another question. When can we find a blog? I think that's probably for the last
Yeah,
talk.
that's from the
Yeah,
previous
yeah,
presenter. Yep.
right. So I think
What is your biggest challenge now?
what is our biggest challenge? Let's see. Well, the biggest challenge is just like Cipher as a language for the graph data in the database. Having a language itself helps a lot in the development of the technology. And the graph is super suitable for visual analytics. Unfortunately, there's not a language being developed for visual analytics, and we are actually in the front line of pioneering this creating this like a visual language for data operation. And so my hope is more companies, more researchers can start getting involved and push this forward.
Mm-hmm.
Yeah. Let's see I see how many in terms of data points and for people to comprehend. Right. So the data points itself, let's say if you put in the database, that's pretty much unlimited. In the visual presentation, the current form we support 100,000 nodes, but we have a version can support much more millions of nodes, and for people to comprehend, there's a couple strategies. One is you reduce that to a few, like hundreds of I think hundreds is comfortable, or if not tenth of the nodes for the presentation. The other way is you kind of group them into some sort of structure way, so you can actually make sense of the overall structure. In that sense, you can actually have a much more data points to be able to understand. Yeah.
Excellent.
Yeah. Thank you so much.
Any other questions?
That's it.
I think that's it.
Yeah.
Thank you very much, Weidong. We
Thank
appreciate
you.
it.
Thank you.
Okay.
Have a wonderful
Bye-bye.
evening. Bye.
Thank you.
Yeah.
Bye-bye.
Bye. Let's see.